Okay, so here we have a problem where we're going to condense. And before I write my final answer, I am going to completely condense. So I'm going to start by taking my coefficient here, and I'm going to turn it into a power. Now that 1/2 is a, okay, so let's take that 1/2 power, which is a square root, okay? And notice here that only the root 5 is in the radical. Okay, so now I notice that I have the subtraction, which is going to turn into the division. So now that I have those two logs, okay, we're going to have square root of 125x over the root 5 and the x. Now that is condensed into one log, single log, with a coefficient of 1. Okay, but I'm not quite done. I do have to look at this inside piece here and try to actually simplify the root 125x divided by root 5 times x. So I'm going to start with the two pieces in the square roots. Okay. Notice this x that is not in the square root, I'm just leaving it there. So we end up with 25x, okay, which is actually just 5 root x over x. Now notice that we still have two x's here, and so I'm going to go ahead and combine them. So this is x to the 1/2 and x to the 1. And so when I combine them by subtracting the exponents, I get minus 1/2. Whew. Okay, so this right here, after I simplify everything in those parentheses, turns out to be log base 5 of 5 x to the minus 1/2. Whew. Okay, this would be the simplified, condensed, single log answer. But it is possible that you write this in a slightly different way. Notice here that the 5 and the 5 match so nicely, okay? And so I'm going to separate this. After I fully condensed, I'm actually going to choose to separate this into two parts. Log base 5 of 5 plus, okay, the exponent comes down, so it turns into minus 1/2 log base 5 of x. And the reason I did that is this piece right here turns into 1. Now, this is not necessarily a condensed statement, but it is equal to this box in blue. It's just written slightly differently. All right, now we're going to do a little bit of review of the inverse properties here. So inverse property is not actually a new property. I'm going to start by evaluating these log statements. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Okay, this one's a little trickier. Log base 25 of 5. Now, if it doesn't take a power to get from 25 to 5, then possibly it takes a root. Well, that's a square root. But I will go ahead and, right, it's a square root to get from 25 to 5. But I'll do the change of base formula just because. Let's see. I'm going to change of base to 5. Okay, which is 1 and 2. Okay, check. So it's log base 25 of 5 equals 1 over 2. Now this one seems a bit trickier with this weird cube root in here. But I do notice that 25 and 5 are here. So I am going to change this to base 5. Okay. Log base 5 of cube root 25. Okay, so this is a 1. Now, how do I get from 5 to 25 to the 1/3? Well, I'm pretty sure that is a 2/3 power because I have to square it to get to 25 and cube root it to get to the cube root. Now this is equal to 3 over 2. Okay, so this is 3 over 2. Sometimes this log statement might be a little bit tricky, but you can do it. Now, I like the change of base method, okay? There is another method, which I will show you. Okay, so I'm going to take this piece right here, and I'm just going to swing it up here. All right. The cube root of 25 to what power equals 5? And I'm just going to start to rewrite this with my exponent rules. Okay, so I turn my cube root into a 1/3. Now I'm going to turn my 25 into 5 squared. Now notice here that we have the same bases, and so if we have 5 to this power in the red box and 5 to the first, it seems likely that everything in this red box should equal 1. So I'm going to multiply by 3/2 on both sides, and so you get a 3/2 power. All right, so now that you've got a little bit on evaluating these log statements, I'm going to turn it into the questions you see in your homework. Okay, so now I have included some problems that have x's in them. And notice here that my exponent or my power property says that this x will come in front, okay? And this log base 2 of 2 will stay. But as you've already told me, log base 2 of 2 is equal to 1. And so we get x times 1, which equals x. Whew, okay. So similarly, we have the power becomes the coefficient. And then we have log base 2 of 4, which you've already told me is equal to 2. And so the result is 2x. Okay. Similarly, even though this exponent has 2 pieces, the whole piece comes down in front. And as you've already told me, log base 25 of 5 is equal to 1/2. And so the result is 1/2 x plus 1. Okay, now here the exponent comes in front, and as we have already discovered, the log base cube root of 25 of 5 is equal to 3/2, and so my result is 3x. I hope that helps you with your inverse questions. Please let me know if you have any others.